All right, so chapter 5 is dealing with ratios, and really, you guys, what it is combining two different fractions and making them be an equal statement before it's all said and done. But before we end up at the end of chapter 5, when we learn how to do all these different things with fractions, we have to first learn all the different ways to write a ratio, all the different wordings that a ratio can be said as. So in this first slide here, we'll go ahead and write down these key words here. So if you'll look here and kind of follow along, I'll just read through this. First of all, the definition: a ratio is a comparison of two quantities. Ratios can be part to part, or part to whole, or whole to part, meaning it can be pretty much anything that you want. You just have to read what the problem says. So 2 red crayons to six blue crayons. So that's saying the 2 red to the 6 blue. 1 red crayon for every 3 blue crayons. 3 blue crayons per 1 red crayon. 3 crayons for each red crayon. 3 blue crayons out of every 4 crayons. 2 red crayons out of every 8 crayons. All of these ratios are just talking about these crayons that are over here to the right. The ratio of A to B can be written as A colon B. There's actually 3 different ways we can write the ratios. The 3 ways look like this. We have A to B, we have A colon B, and we have A over B. Those are all 3 ways that you can write a ratio. And again, you just really have to read what the problem is asking. So I'm just copying what the book has for examples here, and I'm going to talk through them with you. Again, we just have to read what the problem is asking and basically count up what's there. So write a ratio of pennies to quarters. So I want pennies to quarters. So the first thing I want is pennies. I have 1, 2, 3, 4, 5, 6 pennies. Then I'm going to put 6 for my first number, just like they did here. They put 6. And then 2 quarters, so it's going to be 6, 2, and then I count quarters: 1, 2, 3, 4, 5, 6, and 7. So pennies to quarters would be 6 to 7. Again, you could write 6 to 7 with the word 6 colon 7, or 6 over 7 even. Write the ratio of quarters to dimes. Well, I already know that there's 7 quarters because I just counted them up. So I'm still going to use 7 for quarters, but I do have to count the dimes. I have 1, 2, 3 dimes. So 7 to 3 would be the ratio for quarters to dimes. Now, you have to take into account that means quarters to dimes. If I were to say dimes to quarters, that would change the ratio. But quarters to dimes is 7 to 3. Write the ratio of dimes to total coins. So again, dimes is still just 3, but then when it says total coins, what I need to do is take them all and add them all together, or I could just count for total: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the ratio is going to be 3 to 16, or you could write the word 2 or the colon. Now, one thing that this example did not do a good job of catching is the fact that sometimes these fractions or these ratios can be reduced. 6 over 7, 7 over 3, 3 over 16, none of those reduce. But if you ever do get something that does reduce, you have to always reduce fractions. So look for that today in your homework. So here's the time where we're going to take a second and try and write a couple ratios on our own. So go ahead and pause the video. In example 1, write the ratio of dimes to pennies. So go back and look at the picture for that video, for that part of the video, and do dimes to pennies, and write a ratio for that. And then for 2, it says the circle graph shows the favorite ice cream toppings of several students. Use the ratio language to compare the number of students who favor peanuts to total students. Okay, so in the previous video, there were 3 dimes. So 3 is going to be the first number for example number 1. 3 is our first number. So there's 3 dimes and 6 pennies. So I'm going to reduce that to 1 to 2. The next example, example 2, it says that Peanuts 2 total number of students. So what I need to do is I need to use the fact that I know that there are 5 students who like peanuts, and then I have to add up the rest of them and say 5 out of total students. So I need to add up all of them in that circle graph. So 5 of them like peanuts, 1 more likes caramel, 4 likes sprinkles, and 9 likes fudge. Well, if I add 5, 1, 4, and 9, I end up at 19. So the ratio for that is 5 to 19. 5 over 19 doesn't reduce, so we're going to leave that one alone. But again, notice that we have that one up above that did reduce. Tape diagrams are kind of like a bar graph. You guys will pick up on them pretty quick. Ratios with tape diagrams basically are showing you the different lengths of these horizontally as opposed to vertically with a bar graph. So it says the ratio of your monthly allowance to your friend's monthly allowance is 5 to 3. The monthly allowance is total $40. How much is each allowance? So it looks like this is kind of a hard thing to figure out. But if I know that the total of all of these things is $40 and the ratio is 5 to 3, I have to take the fact that each one of those things is going to be the same amount of money. So if it's 5 to 3, I'm going to assign a variable to all of those things, and I'm going to say, okay, I have 5 to 3, so I have 8 total things, and they're going to be x's, and I know that 8 of those x's is going to be equal to 40, because it says those 8 parts represent 40. Well, if I divide 40 by 8, I get 5. So I get x equals 5. So when it asks how much allowance do I get, well, I have 5 x's. So for me, I have to take 5 times 5 to figure out how much money I get, which is 25. For my friend, I have to take 5 times 3 because he only has 3 of the pieces, so his allowance is only $15. But that's how we figure those out. Again, replay the video if you don't kind of keep up with that, but it's very simple. You just assign a variable to each piece of tape and then solve it like you would a one-step problem. So this is similar to what we did in example 2. It says you separate 42 bulbs of garlic into 2 groups, one for planting and the other one for cooking. It says you will plant 3 bulbs for every 4 bulbs that you use for cooking. Each bulb has about 8 cloves. About how many cloves will you plant? Well, it says right here, to help visualize the problem, express the ratio as a tape diagram. We have 6 of each of these things for planting, and then 6 of each of the things for cooking. So if you'll see here, we have 3 times 6 equals 18, and then 4 times 6 equals 24. So it says we have to take 18 and 24. So 18 and 24 will be the total number of bulbs that we have, but you'll see that the question asks how many cloves will you plant? It says that each clove is part of the planting. So what we have to do is we have to take those 18 parts that we found from the total number of garlic, and we're going to take it times about 8 because there's 8 cloves in each piece of garlic. And we get 18 times 8 is 144. This one's a fairly complex problem. I don't really foresee you having too many that are like this, so don't stress out too much over this one. Okay, for the purposes of your problem, I copied example 2 back onto this page and put it so that you could solve it, except for your tape pieces won't be the same. In yours, it says right here that your friend and you are 2 to 3. So you this time are 2 pieces of tape, and your friend is 3 pieces of tape. So they have 1 more piece of tape than you. And we still are going to total $40. So do the same thing that we did in example 2 and figure out how much money you make. Okay, so again, what we do is we assign a variable x to all of these things, and if we know that the total of these things is going to equal 40, I'm going to say 5x's equals 40. Then I can divide to figure out what number times 5 is equal to 40, and I get my answer x equals 8. But this time all I have is 2 x's, so my total is going to be $16. My friend's total, he has 3 pieces. He's going to have 3 times 8, which is $24. So that's kind of the difference between those two.